okay, Q of n minus k. All right, and what this really is this is just if this is the probability of Q would just be this. Make it real simple. Q is 1 minus the probability of P. Okay? So this would, if P is the probability of a medical call, then this is the probability of a fire call. Okay? So it's just the opposite one. Little difficult to understand, but when we go through the example, it will come out. All right, now what's this guy here? This is like a counter. Okay, this is called combinations. Okay, combinations. And I didn't do a video on that, but I'd like to. Combinations is the various possible ways of picking something k times. So if you have n is all the picks, what your k successes would be of n possible times. Okay, so let's see what we have here. This formula of combinations comes out like this. We have nck is going to be given by n factorial over k factorial n minus k factorial. So there's the formula. This is a general formula for the combinations. Okay, and by the way, if you have a calculator, you'll see many calculators have this formula. I have mine right here, NCR it's called instead of NCK. So NCR. We'll probably do one of those shortly and on my calculator, and you can see how that works out. You probably have one on your calculator. Okay. All right, so go back to the problem here, and we have to find out the probability that all 4 calls are for medical help. Well, I'm not going to go into construction of the binomial theorem or construction of the binomial distribution from the binomial theorem. Suffice to say that the binomial theorem is out there, and it's just 2 terms, so it's binomial. It's 2 monomials, and that's why they call it binomial, and it uses Pascal's triangle for simplicity to without doing all the FOIL method. You could actually expand something that looks like this. If you have, say, a plus b to the n, and say this was a plus b to the 6th power or something, this would be a bit of a job. But with the binomial theorem, okay, you can use that to expand these terms. And then when you apply it to the binomial distribution, okay, and that allows us to calculate the probabilities, okay, of events in a distribution. So that's a longer topic than I can do at the moment on a 20-minute video. So, all right, so we're going to get to work on number 1. Find the probability that 4 calls are for medical help. All right, and remember, in factorials, the factorial of 0 is equal to 1. Okay, important to remember that. Okay, so what we want here in part A is we want the probability that we get that K equals 4 successes. Okay, all 4 successes when n, the total number of trials, is 4. So n is 4. All right, so all right, successes. What did we define as successes? Successes are when we have a medical call. All right, because all 4 calls are for medical help. Okay, so n N is 4. Okay, we're doing 4 trials, which means there's 4 phone calls. Okay, we want to get 4 successes, which is a call for medical help. Okay, well, each success would be 1 call for a medical help. Okay, so we're going to put it into this formula here. First thing in the formula is this combination. All right, so n on top is 4 factorial over k, okay, which is 4 factorial, and then 4 minus 4 with end parentheses factorial. Okay, so that goes in front. That's your combination counter. Okay, then the probability of a success. Okay, to the k power, raised to the k power. So what's the probability of success? Well, the probability of success here is 81% of incoming calls are for medical help. So we're going to say, well, that's 0.81 raised to the 4th power. K is 4. Okay, and then Q is the difference between, well, that's the failure probability. So the failure probability would be 1 minus 0.81, which would be 0.19. Okay, raised to the 4 minus 4 n minus. Okay, so there you go, and that'll give us the probability. So this equation is just lovely. The problem is to derive it, and all we have to have another video. Okay, so we're not going to get to it in this video. All right, let's run some numbers. Well, this would then equal, well, these probabilities are going to cancel out. 4 factorial is 4 factorial cancels out, and then you have 4 minus 4 is 0, so it's really 1. All the combinations here just fall out to 1. Like I told you, 0 factorial is equal to 1. So it's 1 divided by 1 is 1. All right. Now I have to get this 0.81 to the 4th power. 0.81 raised to the 4th power is 0.4305, I guess. And then we have to get 0.19. Well, 0.19 raised to the 0 power. Anything raised to the 0 power will just be 1. So I forgot to raise this to the 4th power. Oh, that's done. I did that to the 4th. So there it is. The probability then is the probability of 4 calls out of 4 trials. Okay. Being medical equals 0.4305. There you go. That's A. Done. Now, what's the probability of the 4 that all 4 calls are for fires? Okay, so that would be part B. All right. Well, now we're going to just have to change what we call success. So here I'm going to say success, okay, equals a fire call. Okay, so and that probability of success for a fire call would be equal to 0.19. Okay, so there's your probability. All right, again, same thing. We're getting 4 calls. We're monitoring 4 calls, so n's 4 doesn't change. Okay, so we're going to run this equation again. Well, we have the probability of k equal 4 successes, okay, of fire calls, all right, equals the counter. Now the counter we just did for when you have 4. I'm going to show you that the counter doesn't change when you have 4 n equals k, the counter goes to 1. Okay, so take a look. So you're just going to put it in here again, 4 in case 4, and n minus 4 is 0. So it all goes to 1 again. So you just have 1 here. Then you have, but the probability of success is not the same. Now the probability of success is 0.19 raised to the k power, which is 4. We want all 4 calls to be fire calls. Okay. And then finally, you would have the other one here, which would be 0.81, but that would be raised to the 4 minus 4. So that would just goes to 1. Okay, anything raised to the 0 power goes to 1. And so we have just simply 0.19 raised to the 4th power. So we have the probability that all four calls would be for fire would be 0.194, or this is 19.4% chance. You could also argue this would have been 43.05% chance of all calls being for medical. So there you go. That's the first. What is the probability that one of the 4 calls are for fires? Okay, so here's C. All right, so this is the probability of all 4 calls. All right, so now the counter is going to come into play because the combination counter is going to not go to 1 in this case. So let's run the combination counter here. So we got C. All right, N is 4, but you're going to have 1 call for fire is success. So the combination is 4C1. And that will be run out to be N, which would be 4 factorial, all over K, 1 factorial, and 4 minus 1 factorial. All right, so this is 4 times 3 times 2 times 1. Well, 1 is 1. Then you'd have 3 here, so you'd have 3 times 2 times 1. So all these cancel out, and I'm left with 4. So the entire counter goes to 4. Okay, so the probability that K equals 1 success, that's 1 fire call, okay, out of 4 calls, okay, equals 4, the counter. All right, looking at the formula, the counter's 4, and then we have the probability of K. The probability of success would be 0.19 raised to the 1 power. K is 1 here. And then we have the probability of failure, 0.81 raised to the 4 minus 1. So the 3rd power. Okay, so this would be 4 times 0.19 and whatever that number is. So let's see what we get here. I have 0.81 raised to the 3rd power, 0.5314, and then I'll just multiply the string out, times 0.19 times 4. Okay, so I have 0.403, so 40.3%. Okay, chance. So it's a very high chance that one of the calls will be for fire. Okay, well, it makes sense because the probability is about 20%, so it makes a lot of sense. All right, I'm going to flip this over, and we're going to now proceed with the more complicated problem here that they gave us, and that is when you get these, at least one of the calls for fires. But I just want to show you one thing here. On my calculator, I actually have a permutation and combination calculator. Okay, so if we were doing this 4C1, I would just put in 4. I would hit this kind of swivel key, okay, is proportional to T, right? And then I would put 1, and then I would do second combination, and I get 4. See that? So it actually does the calculation for me. Now, if I did this for permutations, I would just go 4, swivel key, 1, and then permutations would be 4 also in this case because you're taking. But if you did some other value, you would end up getting more permutations would be a higher number than combinations. Okay, let's switch over. So I don't have to do the calculation of combinations unless you want me to, I guess. But let's see. I'm going to rewrite the equation just so we have it in front of us. Okay, and the equation for this, okay, is right here. We have P of success, okay, equals NCK PK Q N minus K, where P equals the probability of success, okay, each trial, and Q is the probability of failure each trial. Okay, so this never changes, as you know, for this condition, and the counter is just the NCK. Okay, and there you go. Here's your equation. Now let's go on to part D. All right, so part D is saying that the probability at least one of the calls is for fire. So basically what you're saying is the probability at least one success, okay, out of 4. So at least one success. So that's one fire call, okay? Now, that I have to tell you is actually equal to the probability of 1 success plus the probability of 2 successes plus the probability of 3 successes plus the probability of 4 successes. You see? So you have all of these are the probabilities that have to be considered because you have to add them up, okay? And that's the way you handle this. All right, so we already have the probability of 1 success from our previous example, and that was 0.403, okay? So this one here would be 0.403. Okay, there's your probability of 1 success, all right, from the previous part of the problem. All right, now we have to do the probability of 2, probability of 3, probability of 4. So, like I say, the counter would come in handy here. So let's just put in what we have here for the probability of 2. Okay, I'm going to get 4C2, the 0.19 to the 2, and then I got here 0.81 to the 4 minus 2, okay? And then I'll do the probability of 3 is 4C3, 0.19 to the third, 0.81 to the 4 minus 3, and finally probability of 4, which I think we already did. The probability of all 4 fires was going to be, okay, we did this one too. So we're done with that. And what do we get for that number? We have, that was the first part, right? The second part, B. So we have 19, 0.19. So that's 0.19. So we're done with that. We got part 1 here and part 4. We need part 2 and 3. Okay. Like I said, I got the counter for the combination counter. So let's run with that. So I'm going to put in 4 is proportional to the proportional symbol T, proportional to 2 and 6. So that's 6. The counter is 6. Okay, and let me do this one. And I could do it the long form for somebody if they want it. So I'll do one of the long forms. So, okay, so in this case, 4 proportional to 3 second, and that's 4. Okay, so let me do this number 2. So if you do 4 combination 2, it's actually sub 4 combination 2, you would get 4 factorial over k, right? K here is 2 factorial, 4 minus 2 factorial. Okay, that's 4 times 3 times 2 times 1 over 2 times 1, and this would be 2. So this would be 2 times 1. Okay, the 2 times 1 crosses out, and I end up with 12 over 2, and 12 over 2 is 6. So you see, I do get 6. So my calculator is working. All right, now let's continue on and get these numbers. All right, so I'm going to put in the string here. So 4 minus 2 is 0.81. All right, 0.81 to the second power times 0.19 raised to the second power times 6. So this number here would equal 0.1421. There you go. All right, let's get this guy. All right, this would be raised to the 0.81 raised to the first power of just 0.81 times 0.19 raised to the third power times 4. And this number would be 0.0222. Okay, so let me check this one, make sure this is right. So this is 0.81 raised to the 2 power, okay, times 0.19 raised to the 2 power, okay, times 6. Yep, that's right. All right, so there we go. Let's add them all together now. So the probability at least one fire call, okay, equals 0.403 plus 0.1421 plus 0.0222 plus 0.19. Okay. Let me see the probability of, right, okay. 0.19. No, I made a mistake. It's 0. We have it here. The answer's 0.0013. Okay. Makes no sense that the probability of 4 calls will be higher than that. So I picked it up on that. 0.0013. Okay. You got to always be asking yourself, does it make sense? So the probability will drop down as we go across. Okay, so here we go. 0.0013 plus 0.0222. Okay, plus 0.1421 plus 0.403. Okay, here we go. We have 0.5686. So there you go. About 56.86% chance of getting a call, at least one fire call. So it's pretty high. And that contrasts with when we were going to get the success of at least one fire call is pretty good. Okay. Now, one of the calls would be C, so it would be 40%. So you have a 40% chance of one call, and here you got a 56% chance of at least one call. Could be the so you're going to add a few of some probability to that probability, so it's going to be higher. You expect it higher, and it's fine. All right, the last problem here, goodness gracious, is problem E, and that's saying that we have what's the probability of at least 2 successes. Okay, and when we define a success as a fire call, at least 2 fire calls. Okay, the formula, we don't need to rewrite it. This time we have it here again. All right, so we need to figure out, well, that probability would be equal to the probability of 2 plus the probability of 3 plus the probability of 4. Okay, so at least 2, but then 3 also works and 4 works. So basically what I see here is we're just taking the probability from part D, and we're going to subtract the probability of 1, and then we would have it. So we'd have the problem solved. So what did we have here? We had 0.5686, okay, was the total from part D, minus the probability of 1, which was 0.403. All right, so that probability would drop off significantly. So we're going to see 0.5686 minus 0.403, and I get 0.1656, which is about 16.56%. Okay, there you go. And interestingly, in these books, there are some things that are going on here, and I just wanted to bring it to your attention, and that is they have these tables in these books, and when you're saying the probability is less than or equal to some number, you can pick up this table and you would be able to calculate the sum of all the probabilities whenever you're dealing with a problem. Okay, so here you have 2 trials, okay, and the number of successes would be your A, okay, and these are the probabilities of success going across, and then you'd be able to read in the table. So if you have 0 successes out of 2 trials, that would be the, if you had probability of success was here 1%, that would be your chance, okay, of the cumulative, at least, what is it, X or less than A, right? So that would be your probability of success less than 1, okay? So less than one success. So pretty high. You wouldn't get it. So these also keep going up in numbers. So you get, like, for our problem, n is 4. But this is the probability of less than A, okay? So you would all the probabilities would add up to 1, right? So you would have to figure out what was less than the number you have, and then go from there. Okay, so I don't know. This is a little complicated, but I wanted to say that there are tables you could use. I don't want to do it right now because I think the video is pretty long, and basically that could be another video reading into this, but there are tables that can help you do these problems. Be aware. Okay? Thank you. Have a good day.